In section 10.2, we're looking at rational exponents. Our objectives are to understand the meaning of a to the 1 over n power, and a to the 1 over n power we can say is the nth root of a. The second objective is to understand the meaning of a to the m over n power, and a to the m over n power can be written as the nth root of a to the m power, or the nth root of a all raised to the m power. The third objective is to understand the meaning of a to the negative m over n power. Remember, negative exponents you can make positive by moving them either from the numerator to the denominator or denominator to the numerator. A to the negative m over n is the same thing as 1 over a to the m over n, and by the previous objective that can be written as 1 over the nth root of a to the m, or 1 over the nth root of a all raised to the m exponent. Our next objectives are to use rules for exponents to simplify expressions that contain rational exponents, and to use rational exponents to simplify radical expressions. Use radical notation to rewrite each expression and simplify if possible. 25 to the 1/2 power can be written as the second root of 25, and that's the same thing as finding the square root of 25, which is 5. So 25 to the 1/2 power can be written as 5. 8 to the 1/3 power can be written as the cubed root of 8. And the cubed root of 8 is 2, because 2 to the 3rd is equal to 8, so the cubed root of 8 is equal to 2. And that's our answer. In example C, we have the fraction 1 over 49 raised to the 1/2 power. That's the same thing as taking the square root of 1 over 49, and that is 1 over 7. The square root of 1 is 1, and the square root of 49 is 7, so the square root of the fraction 1 over 49 is 1 over 7. The quantity negative 8 raised to the 1/3 power can be written as the cubed root of negative 8, and that answer is negative 2. If you take negative 2 and raise it to the 3rd power, you get negative 8. Now 16x to the 6th all raised to the 1/2 power can be written as the square root of 16x to the 6th power. We can simplify this. We know the square root of 16 is 4, and the square root of x to the 6th is x to the 3rd. That is our answer. We can check that. We know that 4x squared, 4x to the 3rd, that quantity squared, is 4 squared, which is 16, and power to a power we multiply to get x to the 6th power. 81 to the 3/4 exponent can be written as the 4th root of 81 to the 3rd power. Now you can do this a couple ways. You can begin, which I recommend doing, first the 4th root of 81 and then raising that result to the 3rd power. Since 81 is the same thing as 3 to the 4th power, this is simplified to 3. The 4th root of 81 is 3, and we're going to raise that to the 3rd power to get 27. And 27 is our final answer, 81 raised to the 3 over 4 exponent. In example B, we have negative 8 raised to the 2/3 power. So we can write that as the cubed root of negative 8 to the 2nd power. We can evaluate the cubed root first and then raise that result to the 2nd power. The cubed root of negative 8 is negative 2, since negative 2 to the 3rd power is negative 8. And then we could take that result and raise it to the 2nd power to get 4 as our final answer. 32x to the 5th all raised to the 2/5 power can be written as the 5th root of 32x to the 5th, all of that to the 2nd power. And again, we can evaluate the 5th root first before we square the quantity. So we want to find the fifth root of 32x to the fifth, and then raise that final result to the second power. And the fifth root of 32 is 2, because 2 to the fifth is 32. So this can be written as 2, and the fifth root of x to the fifth is x. Now we're going to take that quantity and raise it to the second power. 2 squared is 4, and x squared is x squared. So our final answer, in simplified form, is 4x squared. The quantity negative 16 raised to the 3/2 power can be written as the square root of negative 16 to the third power. We could also consider this as the square root of negative 16 and then raise that final result to the third power. But we have a problem here because you can't take the square root of a negative number. Any index that's even, you cannot take the square root of a negative, or a fourth root, or a sixth root, or any even root of a negative number. So this is not a real answer. Let's simplify if possible and write our final answers with positive exponents. Let's begin by writing 8 to the negative 2/3 using a positive exponent by moving it to the denominator, where we'll keep 1 in the numerator and 8 to the 2/3 in the denominator. We can simplify the denominator and write this as 1 over the cubed root of 8 to the second power. We can evaluate the cubed root first, and we can write this as 1 over the cubed root of 8, and then raise that result to the second power. And we know the cubed root of 8 is 2, so this can be written as 1 over 2 to the second power, or 1/4 as our final answer. We've simplified 8 to the negative 2/3 to be equal to 1/4. In part B, we have the quantity negative 64 raised to the negative 4/3 power. Let's begin by writing this as 1 over negative 64 to the positive 4/3 power, and then we can evaluate the cubed root first. So we can write this as 1 over the cubed root of negative 64, simplify that result, and then raise it to the 4th power. 1 over the cubed root of negative 64 is negative 4, sorry. So this is 1 over the cubed root of negative 64, which is negative 4. And then we're going to raise that to the 4th power. And negative 4 raised to the 4th power is 1 over 256. So our final answer simplified is 1 over 256. In part C, we have 1 over x to the negative 2/3 power. We want to make that negative exponent positive by moving it to the numerator to get x to the 2/3 power. Now it is possible to leave our answer in this form. Our final answer does have a positive exponent, or we can write this as the cubed root of x squared. Either one of those is acceptable. So our final answer can be written as x to the 2/3 or the cubed root of x squared. In example D, we have 3 over 4x to the negative 5/9 power. We're moving only the portion that has a negative exponent. So this fraction can be written as 3 over 4, and then that x to the negative 5/9 in the denominator, we move it to the numerator, and it becomes x to the positive 5/9. You can leave your answer in that form, or you could write this as 3 times the 9th root of x to the 5th all over 4. Either one of those is acceptable. If you're asked to give your answers using only exponents, then the first answer is sufficient. Now we're going to use the properties of exponents to simplify each expression and write with positive exponents. We have x to the 4/3 times x to the 5/2. We're going to use the product rule for exponents, where if the bases are the same and you're multiplying, then you add those exponents together. So this becomes x to the 4/3 plus 5/3 in the exponent. And when you simplify that, add those fractions together, you get x to the 9/3, which simplifies as x to the 3rd. As our final answer, x to the 3rd. In part B, we want to add those exponents together as well because the bases of y are the same. So we could write this as y to the 5/3 times y to the negative 1/3 is the same thing as a base of y raised to the 5/3 plus a negative 1/3. When you simplify this, you get y to the 4/3, and we can leave our answer with positive exponents, and y to the 4/3 power is our final answer. In part C, we're going to use the quotient rule for exponents, where if the bases are the same, you can subtract the exponents. So this is going to be x to the 3/5 minus 1/10 for the exponents. And when you simplify that, you get x to the 5/10, which can be further simplified to x to the 1/2 power. That is our final answer. In example D, we can simplify what's inside the parentheses. 81 to the 1/4 is the same thing as 4th root of 81 times x to the 2/3 all to the 3rd power. Now the 4th root of 81 is 3, because 3 to the 4th is 81, so the 4th root of 81 is 3. So we have 3x to the 2/3 all raised to the 3rd power. Now we're going to share that exponent with both the 3 and the x to the 2/3. So we will get 3 to the 3rd times x to the 2/3 to the 3rd power. When you have a power to a power, you're going to multiply those exponents together. And when we simplify our result, 3 to the 3rd is 27, and x to the 2/3 times 3, 2/3 times 3 is going to be 2. So our final answer is 27x squared. In example E, in the numerator, we have a to the 3/4 times a to the negative 1/2, and then a to the 4/3. So we're going to use the product and the quotient rule for simplifying this expression. In the numerator, I can add those exponents together. Since it's a to the 3/4 times a to the negative 1/2, I can add the exponents 3/4 plus negative 1/2. That goes in the numerator, and a to the 4/3 in the denominator. In the numerator, we can simplify this to a to the 1/4 over a to the 4/3. Now we can use the quotient rule where we subtract those exponents, a to the 1/4 minus 4/3, and then we can simplify that to get a to the negative 13 over 12. You may want to go back and review how to add and subtract fractions by getting a common denominator. And then we want to write our final answer using positive exponents. So we can write this as 1 over a to the 13 over 12. It's our final answer. All right, let's look at example F. In the numerator, we're going to keep x to the 10/3. In the denominator, we have x to the 4th, that quantity, to the 1/3 power. So the power to a power rule, we're going to multiply those exponents together. And 4 times 1/3 is 4/3. And now we can use the quotient rule where we subtract the exponents. So we're going to get x to the 10/3 minus a 4/3 in the exponent. And then we can simplify that to get x to the 2nd power. 10/3 minus 4/3 is 6/3, and 6 over 3 is 2. So our final answer is x to the 2nd power. In example G, we have the quantity 3x to the 1/5 all to the 4th power, and then in the denominator, x to the 3/10 power. Let's first share this power of 4 with both items in the numerator. So we're going to write this as 3 to the 4th over x to the 1/5 times 4, which is x to the 4/5, all over x to the 3/10. Now we can simplify this. 3 to the 4th is 81, and using the quotient rule for exponents, we're going to take x to the 4/5 minus 3/10, and that will give us 81 x to the 1/2 power. And we can write that as our final answer, 81 x to the 1/2 power. In example H, we're going to share that exponent in the numerator and the denominator. So we're going to have a to the negative 3rd times 1/8. So that's going to be 8 to the negative 3 over 8. And b to the 2nd to the 1/8 power is going to be b to the 2 over 8, which you can reduce to 1/4. In the denominator, we're going to share that exponent of negative 1/4. a to the negative 2 to the negative 1/4. Multiplying those exponents, negative 2 times negative 1/4 is going to be 2/4 or 1/2. And then in the denominator, b to the negative 1/4. Now I'm going to move any negative exponents around. So our next step can be written as this a to the negative 3/2 power. I'm going to move it to the denominator. And b to the 2/8 power, I'm going to leave in the numerator, or you can write b to the 1/4. A to the 2/4, which is the same thing as 1/2, can stay in the denominator. And b to the negative 1/4, move it up to the top, because b to the positive 1/4. Now we can simplify those and add the exponents together. So it's going to be b to the 1/4 times b to the 1/4 over a to the 3/2 times a to the 1/2. And now by using the product rule for exponents, in the numerator we're going to get b to the 1/4 plus 1/4, and then in the denominator it's going to be a to the 3/2 plus 1/2. I'm sorry, that should be 3/8. All right, I made that correction. That denominator should have been a to the 3/8 and a to the 1/2. Now when we simplify, the numerator b to the 1/4 plus 1/4 is 2/4, which is b to the 1/2 in the numerator. And a to the 3/8 plus 1/2, that's going to be a to the 7/8 as our final answer when simplifying that rational expression with rational exponents. In the problem set number 5, we want to use rational exponents to simplify each radical and assume that all variables represent positive numbers. In example A, we have the 12th root of a to the 4th. We're going to write this as a rational exponent. So this is going to look like a to the 4th to the 1/12th exponent. And by using the power rule for exponents, power to a power, you're going to multiply 4 times 1/12, and that is 4/12, which is reduced to a to the 1/3 power. 4 times 1/12 is 1/3. And then finally we can write this as a to the 1/3 power, or writing it as a radical, we write this as the cubed root of a as our final answer. For part B, we have the 4th root of 25, and we can write this as 25 to the 1/4 power. Doesn't look like we can do much simplifying there, but actually 25 is a perfect square, so we can write this as 5 squared to the 1/4 power. And then we can use that power rule for exponents, multiply those powers together to get 5 to the 2nd to the 1/4 by multiplying 2 times 1/4. We get 1/2, and then we can simplify this as the square root of 5 for our final answer. In part C, we have the 4th root of 64x squared, and we can write this as 64x squared all to the 1/4 exponent. And 64 is the same thing, if we write it using exponents, that's the same thing as 2 to the 6th power times x to the 2nd power to the 1/4 power. And then what we can do here is use the power rule for exponents. So this is going to be 2 to the 6th to the 1/4. We're going to multiply those exponents together. 6 times 1/4 is 6/4, which reduces to 3/2. And then x to the 2nd power to the 1/4 power is the same thing as 2 times 1/4, or 1/2. Now we could write this as, taking those denominators of the exponents, writing that as a square root of 2 to the 3rd times x. And then later on, actually in the next section, we're going to explore this even further. You could take out perfect squares when simplifying rationals or radicals. And this can also be written as 2 times the square root of 2x. In example D, we have the 12th root of the quantity a to the 6th, b to the 6th. So we can write this as a to the 6th, b to the 6th, all to the 1/12th exponent. And then we can share that exponent to get a to the 6 times 1/12th, a to the 6/12th, which is going to reduce to 1/2, and b to the 6/12. So these will both simplify to a to the 1/2 and b to the 1/2. So then we can write our answer as a square root of a times b. Here we're going to use rational exponents to write as a single radical expression. The cubed root of x times the square root of x can be written as x to the 1/3 times x to the 1/2 power. Then we can use the product rule for exponents to add those together. So we can write it as x to the 1/3 plus 1/2, which is the same thing as x to the 5/6 when you add those fractions together. And then we could even write this as a radical expression, with the radical sign, the 6th root of x to the 5th as our final answer. In part F, we can rewrite each of these radicals as a rational exponent. The 8th root of y is the same thing as y to the 1/8 exponent. The 9th root of y is the same thing as y to the 1/9 exponent. And then using the quotient rule for exponents, you can subtract the exponents to get y to the 1/8 minus 1/9. Now that's going to simplify. 1/8 minus 1/9 is 1/72. So we can write our final answer as the 72nd root of y. That's how we can take this expression that has two radicals and combine it into a single radical. In example G, we can take the 12th root of x and write it as x to the 1/12th power. And the cubed root of x squared, we can write that as x to the 2/3 power. Now we can use the product rule for exponents and add those exponents together to get x to the 1/12th plus 2/3. And when we add those, we get x to the 3/4. And writing it as a single radical is the 4th root of x to the 3rd power as our final answer. In example H, the 5th root of 2x can be written as 2 to the 1/5 x to the 1/5. And the cubed root of y can be written as y to the 1/3. Now, in order to write this as a single radical expression, we do need to get a common denominator for all those exponents. The LCD for the rational exponents is the least common denominator for 1/5, 1/5, and 1/3, which is 15. So we can write each of these as an exponent with a fraction with a denominator of 15. So this is the same thing. 2 to the 1/5 is the same thing as 2 to the 3/15, x to the 3/15, and y to the 5/15. I just rewrite each of those fractions with a common denominator of 15. Now I can write this as the 15th root of 2 to the 3rd, x to the 3rd, y to the 5th. And then we can go one step further and rewrite 2 to the 3rd as 8. 8 x to the 3rd, y to the 5th, the 15th root of that quantity is our final answer.